Hey class. So today I thought I'd go over some basic stuff. I shouldn't call it basic, just some stuff that we've been going over in class and how to solve problems that I've been throwing at you. So for the first type of problem, I want to take sketching angles and how to approach this. So one thing that I've already drawn is the initial side of our angle. That's always going to be on the x-axis. So you can always start by just drawing this. The second thing that we can do is we can use our measure of 2 pi. Remember that 2 pi covers this whole circle, right? So we can use that measure of 2 pi as kind of like a measuring stick, if you will. And we can see how many measures of 2 pi are in this angle 4 pi over 3 by just dividing it by 2 pi. Okay? Now, when we do this, we should get a little bit over 0.5. I haven't actually done the calculation, but we should get something a little bit over 0.5. Hold on. Okay, so the calculation is just above 0.5. It's 0.67. So what does this tell us? Okay, well, remember that 2 pi, again, is going to be the entire circle. So this means that it goes a little bit over half of the circle. So it'll be somewhere around here, right? Now, whenever I ask you to sketch an angle that's not in those pi over 3, pi over 6, pi over 4 triangles, it's okay to just approximate where it is. So this right here, let me do it in a different color. The negative y-axis is 3 pi over 2. And if we divide 3 pi over 2 by 2 pi, it tells us that it's going to be 0.75. So it's going to be 3/4 the way around the circle. And this point right here is pi, which is about 0.5. That's half of the way around the circle. So you don't have to get this exact every time. You can just kind of leave it somewhere in between like that. Because again, this is 0.75, this is 0.5, and our angle is about 0.67 of the circle. So it's about halfway between 0.5 and 0.75. So let's not talk about an angle that goes around multiple times and do that. Okay, so here we have another angle, and this is going to go around multiple times. So we can check how many times by, again, just doing the ratio. And let me plug that into my calculator. Okay, this proportion is going to be around 2.08. Okay, so that tells us that this angle goes around a little bit over 2 times. And in fact, this angle, when we know exactly where it's going to end. This is where we can use our coterminal angle formula, knowing that it goes over 2 times, a little bit over 2 times. That means that when we subtract 2 pi times k, we actually already know what our k value is. K is going to be 2. Because what k is k is telling you how many times does it rotate around your kind of like, okay, k is the amount of times that you pass up the 0 to 2 pi range. So let me draw this out and maybe we'll see it. But first let's write down what theta c is. So when we subtract this, this 2 pi is going to become 12 pi over 6. And I'm sorry, I just realized my mistake. So this should be negative 2, and this should be plus 2 pi k. Sorry about that. So we change that, and then we plug in our negative 2 for k. Then we have 25 pi over 6 minus 24 pi over 6, which is going to equal pi over 6. Okay, so now what have we learned from doing that? Well, if we look at our family of triangles, pi over 6 is in the pi over 6 family of triangles. So now we know that this angle goes around 2 times, and it ends on the pi over 6 angle. So we draw the going around 2 times. Because this is a positive angle, it's going to go counterclockwise. So that's going to be 1 rotation. That's 2 rotations. And pi over 6 should be somewhere around here. I don't know exactly, but it should be somewhere around there. And then we draw a terminal side. That is how you draw 25 pi over 6. Okay, so now I want to talk about triangles and why we spend some time learning these. So let's talk about taking something like sine of 25 pi over 6, which is just the angle we drew earlier. So when we drew 25 pi over 6, we saw that it was it wrapped around twice. It went around 2 full times, and then passed up the positive x-axis and stopped in the same place as our angle pi over 6. Okay, so if we were to not draw the amount of rotation, if we just drew the angle, so here's our xy plane, here's the initial side. Our terminal side for 25 pi over 6 was maybe something like that. Alright, well now I'm going to close off this terminal side and this initial side, okay? And let's try to zoom in maybe. Okay, so let's zoom in on this. If we then label just this tiny part of the rotation, the little bit left, this right here is the angle pi over 6. So that angle is pi over 6, and what I did by cutting it off and drawing that red line is I created a right angle. So if I try to zoom back out now, boom, we already know the side lengths of the pi over 6 angle, right? Because we memorize those using the special right triangle rules. Now, sine 25 pi over 6 is coterminal with pi over 6. It stops right there, forms a right angle triangle, and pi over 6 is kind of in the green, right? So if we rotated this special right triangle that we drew up here so that it looked like this, okay? Now we know that we can use the combination of these two facts to evaluate sine of 25 pi over 6. Sine of 25 pi over 6 is opposite over adjacent, so that's just going to be 2 over square root 3. Now, on the unit circle, right, what we might do is set this to, remember in class, if I got to this part in the lecture, we want to set r equal to 1. So actually, what's going to wind up happening is this triangle is going to shift a little bit, and we want our r to be 1. So then our sides are going to look like 2 over square root 3 and 1 over square root 3. This doesn't change the actual value of sine of 25 pi over 6 because, again, opposite over hypotenuse. So we have 2 over square root of 3 over 1. So we still get the same result. But I just wanted to point that out in case anybody had any questions about, changing r to 1. Does that affect anything? So yeah, this is how we can use triangles. We can use the fact that we have the pi over 6, pi over 3, and pi over 4 families to be able to locate where this angle is on the xy plane, and then we can evaluate all of the trig functions of that angle, no matter what it is. Even if it is in degrees, we can do the same thing. So I can actually run through an example with degrees really quickly, and that's where I'll stop for today. Okay, so here we have a angle theta, and it's going to be negative 315 degrees. Okay, so when I was talking about the radians, I said you could see how much, how far the rotation went, or how far the angle rotated, um, by doing the ratio of that angle over 2 pi. Here we can do this angle, negative 315 divided by 360 to see how far it gets. It'll be 0.875. Actually, this is pretty helpful. So if we look at the xy plane, now that we know how far it is rotated, using our proportion rule, we see that first we draw our initial side. If it goes 0.875 times around, so remember how I cut off, this was 0.75, and okay, let me not just jump into this. Why did I think that 0.875 was helpful? Well, if you take 1 and 0.75, add them together, get 1.75, and then divide that by 2, you get 0.875. So if you take 1.75, divide that by 2, you get 0.875. Why is that helpful? Well, remember how I said before I was talking about pi and its ratio was 0.5 and 3 pi over 2, its ratio with 2 pi was 0.75. Remember when I said this? Well, now we're dealing with a negative angle. So this 0.75 is really up here. So this is negative 3 pi over 2, which is approximately 0.75 of our ratio. Technically, this should be a negative. This should also be a negative. And if we look at 2 pi over 2 pi, this is obviously going to be 1. So 0.875 tells us that it is right in between, it is in the middle, it is the average between 0.75 and 1. So it is right in the middle of our x and y axis. So let's show the rotation just for this example. We start on the x-axis, but since we're dealing with a negative, we go clockwise until we get to our terminal side. So that is what our angle looks like. Using our trig functions, how can we evaluate this? Well, one of the reasons why I find the coterminal angle formula helpful is because it tells us right away what angle this is going to be, which tells us which triangle we can use. So theta c is equal to negative 315 plus 360 times k. Here, our k is going to be a positive 1, because again, our goal is always to get theta c in between 0 and 360 degrees. So this theta c is going to be 45 degrees. So this angle theta is 45 degrees, which tells us we can use this triangle. So again, we're going to want to cut off and create a right angle triangle. And I forgot to write what trig function we'll do, so we'll do cosine of negative 315 degrees. So when we create that right triangle, again, we can just kind of rotate our pi over 4 triangle. So this is our pi over 4. This is square root 2, 1 and 1. Cosine is adjacent over hypotenuse, which is going to be 1 over square root 2. So, again, I want to point out that we can set r equal to 1 here by simply dividing both of these by 1 over, or by square root 2. Okay. Also, I want to point out that the reason I could take this as 45 degrees and use this special triangle is because they are coterminal, and we learned that through the coterminal formula. So all of this stuff is connected, and we can use all of it to learn how to deal with angles and solve for the trig functions and things like that, and also graph them. So I hope this cleared things up for you guys. Hope you all have a good weekend, and I'll see you next time.